My topic is analysis of first order RL circuit. Here the energy storage element is 1. So that's why the name is indicated as first order. If both elements are there, that means storage elements are 2, then it is second order. So let us see here what is the analysis we are going to see. I have considered RL series circuit. For this, I need to find the current through these branches. So how the current is flowing, that means what will be the current for this closed loop. Okay, so we know that when you are considering the analysis of first order, we need to consider the initial conditions. Okay, that means what will be the past history of inductor. We know that these are the storage elements. We know that inductor initial resistor, the resistor is initial condition will be resistor itself, whereas inductor will be having two things. Okay, at initial condition it is behaving like open circuit, at final condition it is behaving like short circuit. For this, how it is open circuit and short circuit, in last lecture I have explained, you can go through with that video. So here inductor is open circuit means, before going to that, let us apply the KVL equation. Okay, let us apply KVL equation for this. It is a closed loop. So there are two voltages drops. One is voltage across resistor and voltage across inductor. So here this is the voltage rise and these two are voltage drops. Sum of potential rises equal to sum of potential drops. So potential rise is V, potential drops are V suffix R and V suffix L. V suffix R is voltage drop across resistor is IR, and voltage drop across inductor is L into di by dt. Okay, in order to compare with the homogeneous non-homogeneous equation, what I am doing is I am dividing with L. So if I divide with L, I am going to get the equation as V by L is equal to 1 by R by L plus di by dt. So I can compare this equation by non-homogeneous equation. Non-homogeneous means we are getting some constant. Homogeneous means it is 0. Okay, so dx by dt plus ax is equal to b. So if I compare this equation, what will be x here? X is nothing but I here. X is I. Okay, x is compared here is I. And what about b? B is equal to, b is nothing but v by l when I compare, and a is r by l. So these are the three parameters which we are going to replace it. Okay, suppose if this equation is in the form of dx by dt plus ax is equal to b, for that we are having this solution, that is the formula. This is the formula: x is equal to c1 e power of minus at plus e power of minus at integral b into e power of at into dt. So first part is the complementary function, second part is the particular integral function. So when you substitute, x is replaced by I, C1 is the constant, is equal to e power of minus at. What is a? A is r by l minus r by l into t, r by l into t. So plus this is the complementary, and e power of same minus at only, no, r by l into t integral. Okay, now I have to do integral. What is b? V by l integral v by l e power of at, that is plus r by l into t. So this is the value I am going to have into dt. You need to do now dt. So this is the actual solution I got. But the thing is, so we can expand this term, no? So when you expand this term, this will be the same term, but when you expand here, minus e power r by l into t, and here e power integral, this v by l is constant, no, I can bring it out, and e power of r by l is e power x integral is e power x only, that means r by l. Okay, r by l into t, and integral of this value will be, it is 1 by r by l, which is nothing but reciprocal, no, 1 by r by l is 1 by l by r. This l and l gets cancelled. Okay, and l gets cancelled here. Okay, any leftover terms? This e power minus rl by t and e power rl by t, bases are equal, powers are added. So finally we will have this term is same answer, no, here. So finally we will have I1 is equal to, I is equal to c1 e power of minus r by l into t plus v by r. Okay, this is the actual equation we are getting. Actually if it is open circuit, what will be the current? Zero. But it is not a open circuit, no. We know that initially this inductor is open circuit, that means past history is open circuit, then finally it will become short circuit. Okay, so based on that past histories, let me substitute these equations. So let me clear all these things first. So when t equal to 0, when t equal to 0, let me take the pen. When t equal to 0, at t equal to 0, what will be the current? T equal to 0 means just now we discussed, no, inductor is behaving like past history as open circuit, no. So this inductor is past history is open circuit. So because of that, t equal to 0, when t is 0, past history will be 0 only, no. Open circuit means 0. So I is 0. Okay, if I is 0, I will be 0, no. You substitute this I equal to 0 in the equation number 1. When t is 0 means I will be 0. When you substitute that, the equation 1 with equation 1, you will get as I is equal to 0 is equal to C1 of e power of minus R by L. What is t? T is 0 plus V by R. Okay, here what I am getting, I am going to get the value of C1. Okay, e power of anything, e power of 0 is 1. Okay, V by R, that is C value, complementary value we are getting as C1 is equal to minus V by R. Okay, now you substitute this equation in the number 1. When you substituting, you are going to get I is equal to V by R minus V by R e power of minus R by L into T. Just a substitution. We are getting plus term I have written first, and then minus term. C1 is minus is there, no? Minus term I have written. So from this what I am getting? I am getting I is equal to V by R into exponential term. 1 minus of exponential term, that is e power of minus R by L into T. So this is the current actually I am getting. So we know that if we see the response, see I am plotting the graph for it. If I plot the graph for it with respect to time, so I am plotting graph with respect to time. So here we know that suppose if it is e power of minus means exponentially decaying, no, that is it will be like this. But if I take 1 minus of e power of minus term, let it be any value, 1 minus e power of minus term, if I consider, it will be exponentially increasing. So that's why this value will be 1 minus of e power minus 1 is there, no, e power of that term is there, no, with respect to time. So it will be exponentially increasing. Okay, this is the graph I am going to get, that will be the response. So the question they asked, that analysis of first order RL circuit. Okay, so we are getting the two terms, no, one is V by R term, another one is exponential term, V by R and V by R. This is the steady state current. Two terms we are getting, steady state, another one is transient. Why we are getting it is transient? Why? Because switching, where it is taking to reach unity. Okay, it is taking to reach unity, because DC current means current should be unity, no. In DC means it should be, the magnitude must be unity, but because of this initial open circuit past history is considered, no. So that's why it is taking some time to reach unity. And now let us see the graphs for VR and VL. Okay, two voltages we are having, no. So how will be the two voltages responses? Let us come to the picture. What is the voltage drop across resistor? The voltage drop across resistor is VR is equal to I into R. What is I? I we got as V by R. I we got as V by R into 1 minus of e power of minus R by L into T. This is the equation we got. Into R is there, RR gets cancelled. We will be having V into 1 minus of e power of minus R by L into T. So this is the term we are getting. Now the thing is, how it is 1 minus of exponential. 1 minus of exponential means the graph will be, it will be increasing exponentially. Yes or no? Minus e power of minus means it will decay. Now let us see the same thing for inductive drop, that is L into di by dt. How we will do? We have to do the differentiation d by dt. What is I? I we are having as v by r into 1 minus of e power of minus R by L into T. You just do the integration. This v by r is constant, that is VL by R outside, and integral of 1 d by dt of 1 is 0 minus e power of minus x is e power of minus x only, that is e power of r by l into t. Integral of that one is minus r by l. Exponent term is there, no, we have to do again that integration. This r minus r is there, minus minus gets plus, and this r gets cancelled, and this l gets cancelled. Finally we are having v into e power of minus r by l into t. So this is the equation we are going to get. So it is exponential of power minus. That means the graph how it will be, e power of minus value means if you substitute any values like e power of minus 1, e power of minus 2, it is exponentially decaying. So these two combined graphs I have redrawn here. You just go through with this. So those two graphs will be like this. Let me. So you can see the response. We got the current now. It is becoming unity, and these two, this VR is in increasing and VL will be in decaying mode. Okay. And here why I am writing 0.632 VR. So here I am getting one term, that means time constant. How the time constant? Let me come with that. Here if I consider the time constant, because exponent of exponential term, we got I is what? I is equal to, we got current I as V by R into 1 minus of e power of minus R by L into T. This is the equation we actually got. So for this, the graph is this one, and this is value is 0.632. How this 0.632 is there? Let us take that. Let us take the exponent of exponential. Exponential terms, exponent is what? R by L only, no? That is R by L into T. And how that current graph we are getting, it is becoming unity only, no? The graph is reaching to unity, which is equal to unity. That means time constant we are going to get here, t is equal to L by R. So where t is nothing but, t is called as time constant, because it is the response we are getting as unity. That means time constant, which is called as tau. Simply I can replace this t as tau here. So when I replace this t as tau, so when I replace this, that means L by R value, I am replacing it by tau. So if I replace, what happens? This I will become, I is equal to V by R, I is equal to V by R, 1 minus of e power of minus t. T is there, T I am writing, and R by L is there, no? What is that one? R by L? It is L by R means tau, but R by L means 1 by tau. Okay. So that's why I am writing in the denominator. So this is the final solution of the RL circuit. That means this is the response actually I am getting. That is steady state response and transient response. Two responses I am got. And this time constant. What is time constant? The exponent of exponential term becoming unity, because the graph is getting unity. And if I substitute the values t equal to 0, that means tau equal to 0, tau equal to 1, t equal to 0. If I t equal to 0, I am going to get this term. And if I get a t equal to tau, if I substitute t equal to tau, then what happens? V by R, you just substitute here, I is equal to V by R, 1 minus e power of tau by tau. Tau by tau is 1. E power of 1 is 0. Okay. So, sorry, e power of 0 is 1 of previous value, and here e power of minus 1 value will be there. So, e power of minus 1 is around 0.36 value, 367. So 1 minus of 0.36, if you substitute, you are going to get 0.632. That is the thing I have taken this value. So that is why I got it. And after that, if t equal to 2 tau, if I substitute, it will become 0.78 like that. That means keep on, it will come nearly to unity. That means 0.98 tau, 98 value like that, it will come to unity. So let me show you that values first. When you substitute those values, this is the things. T equal to 0. What is I? This is I ma. I is equal to 0. I is equal to 0.632 V by R. Just now we got this. So it is 0.865 V by R, 0.95, and it is 0.982 V by R. That means the value will becoming unity. That means almost 1. That is I is equal to nearly to V by R. Okay. Thanks for watching. Please subscribe and share. Thank you. Let me show.